Today I'll focus on the core roles and areas of ownership that you'll find within a data organization. There are really just three of them. Of course, each of these three is a spectrum of skills and ownership, and even between companies they could be defined entirely differently. Not to mention within a given company, there might be different departments defining these roles differently. This is because data is relatively new. Really, it's in the past decade or so that most data teams have come into existence, compared to, let's say, accounting, where accounting teams have been around for a very, very long time. So the rules, the processes, responsibilities are well established. Not the case with data. The way it looks today is not the way it looked 5 years ago, and the way it looks today is not the way it will look in 5 years. So we have to just keep that in mind and try to figure out where we are today. Back to these three core roles. The first one, data engineering. It's first because it's the farthest upstream. These are the engineers who are responsible for provisioning the data set. There's raw data that comes from APIs, third-party agreements, proprietary data sets, event logs, device logs. Data engineer has to build the data set. They take this raw data, they structure it, make it accessible somewhere for downstream users, who we'll talk about next. But the key is they really have to be very excellent at coding. Excellent coding, SQL, Python, other languages like Scala also are very helpful. Able to use large data systems like MapReduce, Spark, knowledgeable about cloud services in general. And their job really is to make the data set accessible to the company, a structured, accessible data set. Sometimes responsible for actually building the schema, the organization of the data itself, but definitely they have to make the data set usable. Sometimes there are business intelligence engineers. You'll hear this term. These are basically data engineers responsible specifically for a reporting environment or reporting itself. I'll talk about that in the future, but there are pros and cons with having data engineering own reporting. Next up, data analyst. This is a tricky one because whereas data engineer is sort of new with big data, data analyst is not. Data analysts have been in companies for a very long time, but now it refers to someone who works on big data platform. They work with big data. They are technical enough to access, structure, analyze data. They usually have some statistical knowledge as well. They can create visualizations. But the way I think of it is that these are, the analysts are really interfacing with stakeholders. They are business focused. So they're producing something that is serving a business decision, a product decision, and they usually work very, very closely in conjunction with stakeholders. Often non-technical stakeholders, which just means that they have to be very comfortable communicating, taking some analyses and making it accessible to someone who's making a decision. These are data analysts. Data scientists, this is a tricky one too, because in the last couple of years there's been, I would say, title inflation. A lot of data analysts, people who were data analysts previously or would have been data analysts, decided that they wanted the title data scientist, or the company decided they should have the title data scientist. And so a lot of the activity that I just described with respect to data analysts is actually now concentrated in data scientists. Previously, data scientists were more focused on machine learning, AI, predictive modeling, whereas the data analyst builds reporting and analysis and presentations that go to a business stakeholder. The data scientist is building a model that goes somewhere, sometimes to a stakeholder, but usually into software itself to make a decision at runtime, let's say. So when we're talking about that kind of data scientist, today more and more commonly called research scientist or machine learning engineer, not only do you have to consider the tools, the data, but also how these models will get into production. That's something altogether complicated that I'll discuss later on in a different video. It's a topic unto its own. The way in which a model, a machine learning model, let's say, winds up actually going into production, it can be a tricky topic. So here, these are the three core areas. data engineering, data analyst, data science. And of course, there's discrepancies around the different titles and the responsibilities. But you could think of it as the areas: building the data set, analyzing it for business purposes, using it for modeling and machine learning. A lot of companies would be perfectly fine stopping at data engineer and data analyst. It's more than enough to have that interactivity with the data. You have experts, data analysts working on the data set and providing the insight and feedback you need to make decisions. Only in cases where there are actually machine learning needs, you want to build a model and deploy it somewhere. In those cases, data science is critical.